What is up, guys? Welcome to the Computer Information Highway for your Java programming tutorial number 39. And in this video, we're going to be working on a new function which is going to go along with the merge functions we've been learning over the last few episodes. And this is going to be the reason that we want to merge, or not merge. This is going to be the reason that we want to sort our functions or our like data sets. If we have like really large data sets, I showed you in the last video how we can create an array of random numbers and then sort it. So let's just say 2 million, and it just runs it really quickly, and it's able to sort all the information. If we were to print this back out, I showed you guys in the last few videos that it would actually print out the numbers that we were looking for. So if you didn't see those videos, they'll be posted. You can go and check them out. In this video, we're going to start using the information that we have sorted. So what we're going to do is we're going to create a search function. And you may think, okay, search is pretty straightforward. You can just go through all of the, you can just go through all of every item in the list, and if it's what you're looking for, you can just go ahead and print it out to the screen. And that's perfectly okay. I'm actually going to show you guys how that can work. And then afterwards, I'm going to show you an optimized version of it, which will significantly decrease the amount of time it takes to find any element that you're looking for. So we're going to go ahead and create a function. Let's just call it search. We're going to take in, not search F. We're going to take in an array, and we're just going to also just take in a value. Let's just call this value because this is the value that we're going to be searching for. And basically, the easiest thing that we can do, and I'm going to show you a couple of different ways we can do this using an enhanced for loop and just a standard for loop. The first one's going to be the standard for loop. So if we do for array.length I++, and we can just check if array at index of I is equal to the value that we have. We're just going to print out to the screen the index that it's at. Let's use printf. Printf is just, I don't know if I mentioned it before, I probably did, but I'll just re-explain it real quick. Printf is just going to format a string to contain information that we have. So if what I'm looking for is going to be an integer value, I can put in %d, and this will now take in, or this will print out a integer to the screen. And additionally, what I can do is I can also \tab, and I'll do %d again, and this d is going to be the value that we looked for. And just to make sure that we're finding the correct value, we'll do array of I. That way we know it's actually finding it in the array, and we're not just printing out the value that we had before. So I'm going to limit this between 1 and 1000, and let's just say, yeah, let's just call search array. Oh, I don't think it's called array, it's called unsorted. And then let's just say we're looking for the value 50. Now I'm going to try to generate enough numbers to where it will find it. So let's generate 1,000 numbers. Maybe that's not right. Let's try 5,000 numbers. And what you see here is it's picking out, and this was just bad on my part because I didn't space it out properly. Let me pull that back up. So this is saying, okay, at index 264, we had the number 5 here. Actually, I'm going to fix that real quick. Not swap. We just needed a print line statement in here. So let's run this again. Or we just needed it to print out to a new line. So if we're going to be doing, let's just do, 5,000 numbers. You see it's saying, okay, it found at the position 250, it found the number 50. At the position 251, it found 50, 252, 3, 4, 5, and 6, it found 50. Now, obviously, it's going to find all of the numbers right next to each other because this is after we have sorted our list. And you don't necessarily need to have a sorted list in order to search for values. Say if we were to have our search function decide that or if we decided not to look through a sorted list, we could just say, okay, let's generate another 5,000 numbers. And it's still going to print them out, but you see they're in much different locations because it's not sorted back into place. So we have the numbers all over the place. And on small enough data sets, this is perfectly fine. You're allowed to just loop through until you find it, and that would be that. But there are better ways to do it. And one of the first ones I'm going to show you, well, this isn't exactly a better way. This is just using an enhanced for loop in order to figure it out. So rather than using the standard for, we can do for int I, because we're going to be using integers, and we use this colon to say that we're going to be working within within some array, and we're going to be, or some list, so we're going to be using our array. So this is going to find every integer in array, and it's just going to print it out to the screen. Now we're not going to be able to print out the position of it because we're not actually saving a value, but if we were to do if, so now we're using, since I is the context of what each individual variable in our array is, it's looping through each of the variables in our array. We can say if I equals value, and then we can just print out, actually it might just be easier to copy paste that. So now it will just print out now it should just print out to the screen where the number is located, or what the number is. And we can test that real quick. If we go to run, let's put in another 5,000 numbers. It's able to find 4 instances of the number. And even though we don't have the location of the number, as long as we're able to find it, it's generally okay. If we have multiples, it's not too big of a deal. But when we're looking with different types of data structures like lists, linked lists, arrays, hash tables, things like that, you want to use maybe some enhanced search functions in order to find what you're looking for, rather than just looping through every single value. Because this would take a long time. If you had, let's say 2 billion numbers located within your array, you wouldn't be able to process that as quickly as you should be able to. So this next part that I'm going to show you is going to be how to search for it in a really, really, really fast manner. This is going to cut down the amount of time it takes by almost half. And if you want to look up what the actual speed advantage is for using the search function that I'm going to show you, you can go ahead and look it up. It's going to be called I think it's called a binary search, and it has a very, very basic principle behind it that really is just the simplest understanding for how to use the search function. So basically what we do is we have to take an unsorted list, or we have to take a sorted list because it requires everything to be in order. And if you were guessing numbers, let's say you were guessing a number between 1 and 10, and somebody were to tell you if it's too high, too low, or that's the correct number, you would be able to find the number a lot quicker. For instance, if I had the number 7 stored in my head, we could take the middle number of that, which is 5, and if the value that we're looking for is greater than the number that we found, then we can cut the entire bottom half of it off. So I'm just going to do this right above it. So if I had 1, 2, 3, 4, 5, 6, 7, 8, 9. If I just had these nine numbers, so we would start in the middle, which would give us 4. And then we could say everything 4 and below, since it's not our number 7, we can just get rid of. We don't need to look at any of those numbers. And then we would cut it in half again. We would look right in the middle, which we see is 7. And since the 7 is the number that we're looking for, that's all there would be to it. So in order to program this, we can use a fairly simple search. So this is going to be recursive. And if you've seen a couple of my last videos, you should know how recursion works by now. It's basically just calling the function inside of itself, so that you can repeat the same operations over and over again until you find what you're looking for, or you compute what you're looking for. In this situation, we're going to be searching. So the first thing that we want to do is create a midpoint. And the midpoint is going to be between the minimum value and the maximum value. So rather than using just int value, we can just say, or we can also say int min, int max, and then int value. And the reason we need this is so that we can pass in bounds for our array so that we can ignore a large portion of it when we're recursively going through this function. So the first thing that we do is create our midpoint. So our mid is going to be equal to, it's a very simple average formula. It's the min plus the max divided by 2. So we would just do min plus max divided by 2. And integer, I think integer division will tell us that it will take the smaller number of the two, which is why I was saying it would pick the 4 in the 1, 2, 3, 4, 5 through 9 case that I was talking about earlier. So you'll see, it works out. So then we're going to be saying if, so we want to check to see if the position contains the number that we have, because if it does, there's no reason to continue. So we do if array of mid equals our value. We're just going to actually let's printf again. So we'll do %d \tab %d \n for our new line, and then the numbers that we're going to be using is we're going to be looking at the position of it, which is going to be our mid position, and the second number is going to be the value, just to make sure we're looking for the right one. All right, so and if it's not, then we want to search for the next mid position. And our min and our max bounds are going to change based off of where the value should be located in the array. So we're going to be doing else if. I said else a second ago, but it's else if. And what we want to do is we want to compare the value to the value located at this position. So if the array at position mid is greater than our value, that means that the number that we have right here is bigger than the number that we're looking for. So we can just cut off everything above it. There's no reason to check any higher than where we're located at right now. So we can just call our search function again. So we could do search, and we're going to be searching through our array again, our minimum value. So this is the situation where the number is less than the value we were given, so our maximum bound is going to change to our middle value. So our min value is now going to be, what is it? Our min value is still going to stay min, and our max value is going to do max, and then our value is going to stay the same. Sorry, it's not going to be max. This is going to be mid, and our value should stay the same. And then the last check, which would be if the array is less than min, or if the array at mid is less than our value. There's no need to use another if statement to look for it. We already know that that's going to be the last case that this could process. Then we're just going to be searching our array at mid. Oops, I'm sorry, there's no array at mid. It's just our array. It's going to be our array. And now the minimum value is going to, this is the situation where the value is going to be greater than the value at the position that we're looking for. So it would cut off the bottom half of our list. So that means we would be changing our minimum value to be equal to our mid value. And I'm going to say this is mid value plus 1. And the reason we do mid value plus 1 is because we've already checked the mid value here. So there's no reason to check it again. And then we can just do our max again, and it should, oh, sorry, I didn't include the value. So this should properly search for what we're looking for. If we were to run this, our min is going to be unsorted.length. Sorry. Our min is going to be 0. Our max is going to be unsorted.length. And then our value, we're just going to say again, is 50. So let's see what happens if we run this. So we're going to create another 5,000 numbers. And you see it was able to find the number 50 at location 254 using our new search function. And it's pretty important to know that this is only finding one instance of it. It's going until it finds the very first instance of where value is located. And then that's going to be, because it doesn't keep recursively moving it through the entire program again. It's going to just stop. There's no reason to continue. Once we found our value, this is just going to stop. So you see the search function actually is going to provide us with a lot of increased runtimes, or decreased runtimes, I should say. It's going to be a lot more efficient. And the reason is because it can almost cut the array in half every time it finds a value if it's equal to or not equal to that number, which is much more efficient than looking, say, through a billion numbers or something. I'm just going to play around. Let's see what happens if I set this to like... Actually, let's set this to 1,000,000. And then we're going to run this again. And I'm actually, in order to test one of the cases, I want to make sure that this doesn't ever run outside of the bounds. So what I can do is I can just generate one number. And you see something is going on here. And it's saying that it's searching for the mid value, but you see that the mid value and the max value, even if you were to add them up and divide it by 2, it would be searching in the same spot forever. Eventually, this wouldn't run properly. And I think, so the issue, yeah, it's definitely just searching through it over and over and over again. And the issue is because the difference between the min and the max value is less than 1. And the reason why that's important is because if you try to take the difference of them, you'll be repeating the same number over and over again. Or if you try to find the mid value will continue being the same number over and over again if the difference is minuscule. So it's pretty easy to avoid this collision. We can just say if min is greater than max, oops, not min is greater than max. Max is greater than min. Let's try running that again. Boom, build successful. It wasn't able to find the number 50 that we were looking for, but it was able to take care of the whole bounds issue again. Since the numbers weren't the same, since the numbers weren't the same, it's not just computing the same number over and over again, so there's no reason for it to keep on checking these, and this else statement won't run every time none of these work out. So that's how we use the search function. This is a very, very simple binary search function. I know I put a lot of explanation to something so simple, but it's important to know that you can actually increase the efficiency of your programs by using proper search function or proper sorting functions and proper search functions. Especially whenever you're working with large amounts of data, it can get to be very, very slow whenever you start processing, like, say, thousands and thousands of information, thousands and thousands of pieces of information on, say, like people or locations, or if you're just trying to like parse a simple web page, you could be working with like a ton of different sets of information, and it's important to be able to search through it and be able to find what you're looking for. So that's all that's really going to be included in this video. It was just to get you guys familiar with some search functions and some sort functions. So I think in the next few videos, we're going to be working on a new project. I think we're going to be moving on to some object-oriented programming. Since this is Java after all, Java is known for being an object-oriented language. I think I'm going to try to explain uh, how object orientation works and get into it. And then during that project set, we're probably going to utilize these search and sort functions. That way, you guys see a proper situation in which we can use it. So I will see you guys in the next video. If you like this video, go ahead and like it. If you want to subscribe to my channel, go ahead and do that. It really helps me out. Uh, and thanks for watching. I'll see you guys next time.